Alright, hello everyone. Today we're going to look at two new log properties to go along with our power property we learned last time we met up. And we're going to start with 7-104 in our book. And since logs and exponentials are inverses, the properties of exponents, which are the law of exponents, translate to logs. And so we're going to start reviewing two of those law of exponents, and then we'll kind of do the reverse of those, which refer to the log properties coming up. So for letter A, if you recall, x to the a times x to the b, we can make that a single base of x and add the exponents. Along those same lines, if we have x to the b divided by x to the a, same base, but now we're dividing, we can make that one base of x, but now subtract our exponents. So be x to the b minus a, or whatever's on the top minus whatever's on the bottom. So now we're going to look at some of these logs down here and what properties occur from them. So you will need a calculator, so please get your calculator out. And you will see below here that what we're trying to do is we're going to do log of 5 plus log of 6 and see how we can simplify that. So if you type log of 5 into your calculator, you roughly get 0.6 9. Okay, that's just by typing log of 5 in the calculator. Then I'm going to add to that log of 6. So again, we're just going to type log of 6 into our calculator, and that would give us 0.778. I'll go one more. 0.778. And that means that would equal, and if I add the two decimals together, 1.477, which in this case happens to equal log of x. And if you recall, remember this is log, so that's a base of 10. So if I do my circle dance and do 10 to the 1.477, that would give me what this value is. So right now in my calculator, I'm going to type 10 to that 1.477 power, and that gives me an x value of 29.99. So basically we round to 30. And so we're trying to see if there's a pattern here. Maybe you've seen it, maybe not. If not, let's just do one more quickly. So number 2 over here, we'll do log of 5 again, and that log of 5 is again 0.699. We're going to add to that now log of 2, and log of 2 is 0.301. And when we add those two decimals up, we get 1. And so remember, this is equal to 1. This is a base of 10. And when we do our circle dance, we will get 10 to the first is equal to 10. So that means this x value is equal to 10. So hopefully now you can see the shortcut of, hey, we got a 10 as the x, but we had a 5 and a 2 first. So that means we can multiply the 5 and the 2 together to get log of 10. Or here we had a 5 and a 6, and we got 30 to get from 5 and 6 and 30. Again, we multiply those two numbers in parentheses. So to shorten these up, in general, if we can take log of a and add to it log of b, that would be the same as taking log of a times b power. So if we're adding two different logs, They have to be the same base. We can condense that into one log by multiplying the numbers in parentheses. So please take a second and complete 3, 4, and 5 here. You can use that shortcut now. Pause the video if you need to, and then please go to letter C. Letter C, similar thing. We'd have log of 20, which is 1.301. We're going to subtract that from log of 5, which is 0.699. And when I subtract those, I get 0.602. And so if I go 10 to the 0.602 power, see what we get. We get roughly 4. So x would be 4 here. Do you see the note? See the change here? Here we have log of 20 minus log of 5 is equal to log of 4. The relationship between 20, 5, and 4. Again, we would take 20, divide it by the 5, and we would get 4. So in general, when we subtract logs, again, they have to be the same base. If we have log of b minus log of a, that would be the same as making that in a single log and taking the b and dividing it by the a. So if you need to pause the video, pause it please right now and complete 2, 3, 4, and 5. Alright, now that you have 104 completely finished, we want to write these properties down in our learning log. So if you have not done so already, please get out that learning log and we'll write down our 5 log properties. So you should have the power property written down already because we went over that on the last time we met. So that was the power properties where we take log of b to the x power and take that x and move it in front and multiply it by the log. We use that a lot to get an x out of the exponent and solve for x in the exponent. The new property we learned today is the product property. So that's saying if we have log of b, log of a plus log of b, so when we're adding two logs, we can make that into a single log by multiplying the numbers that are in the parentheses. So that'd be equal to log of a times b. We also learned the quotient property today, which is where we're subtracting two logs. So if I have log of a minus log of b, I can make that into a single log by dividing the first number in parentheses over the second number in parentheses. So that'd be log of a divided by b. We also have our definition of log, which is considered a property. So that would be just doing the circle dance or the bay. Log base b of x equals y is equivalent to b to the y equals x. And we've talked about that a lot last chapter. And then last but not least, we have some canceling properties. If I have log base m of m to the n, those cancel and you're left with just the n. And if you have m to the log base m of n power, again, those are going to cancel and you're left with just n. So, long story short, whenever you have a base of a log equivalent to a base of an exponent, they technically the same, they technically cancel out and you'll be left with whatever is left. Here the m's are canceling out, and again the m's are canceling out. Alright, now that we have that, please keep learning logs out, and we are going to complete 7-106. You can do that directly in your book. This is a little puzzle that we can complete. So it's basically just rewriting using the product and quotient property. So here I have log base 3 of 60. So everything along this needs to be equivalent to log base 3 of 60. So I would start out by rewriting the first one as log base 3 of 6. And I'm thinking, what else could I do using the product property? So then I could have log base 3. Remember, product property means I can multiply these two numbers to get to 60. So this would be log base 3 of 10. Because if I can make this one log, I'd have to multiply those two. 6 times 10 is 60, and that would be log base 3 of 60. For the second equivalency, I could also do log base 3 of 3 plus log base 3 of 20. Because again, 3 times 20 is the 60 we needed over here. That's again using the product property. Over on this side, we're using the quotient property, so that'd be log base 3 of 120, and I can subtract then log base 3 of 2. And we know 120 divided by 2 is 60, so that would be equivalent to log base 3 of 60. And finally, again, we want to use the quotient property, and if I start with log base 3 of 240, and I subtract log base 3 of 4, I just divide those two numbers. 240 divided by 4 is 60, and I would get log base 3 of 60. So from here on out, you just want to fill in all these blanks with appropriate correct logs and rewrite with the product or quotient property as your practice. If you need to pause the video, and then last but not least, I want you to look at 7-108. And the wording in the book might look a little strange, so I kind of gave you a little hint that think about the graph the log. What values of x give a negative output? And we can kind of see here on the graph, these x values give a negative output. So therefore your answer should be between 0 and 1. Alright, please make sure you have the homework written down that is on Google Classroom, and I'll see you next time.